All right, today with Concept X, we're going to be focusing on something called molality and doing a calculation called a mole fraction. So molarity simply just doesn't take into account how much space the solute is going to take up within a solution. Molality is going to allow us to know how much solvent is used compared to the solute. And that's going to later help us figure out the freezing point and boiling point of a liquid. So molality is very similar to molarity, except that it compares the moles of a solute to kilograms of a solvent instead of liters of a solution. Molality is abbreviated with a lowercase m. So molality is equal to moles of a solute per kilograms of a solvent. So our unit is simply moles per kilogram, or a molal. So, calculate the molality of a solution containing 12 grams of lithium fluoride in 200 milliliters of water. Now, our formula is moles of solute per kilograms of solvent. So you can see right now we have 12 grams of lithium fluoride when we need moles, and we also have 200 milliliters of water when we need kilograms. So we're going to go ahead, figure out our moles of lithium fluoride using the GFM, and then we can go ahead and in addition, we're going to need to, let me just set up this pen, ignore the quacking in the background. Okay, we plug in our moles of solute, and then we're going to see that 200 milliliters, because the density of water is equal to 1, that 200 milliliters of water is equal to 200 grams of water, which to get it to kilograms, you divide by 1,000. So 0.22 kilograms. So that's where that number for water is coming from. So again, moles of solute divided by kilograms of our solvent gives us a 2.3 molal solution. All right, number 2. Now we're going to be actually looking for our grams of our solute while we're given our molal solution amount. So here we just need to be aware that we're looking to plug this in so that 0.22 molals is going to be equal to our missing amount of solute over our kilograms of water. So just to show you how you could go about solving this, we have 725 grams of water. The GFM to get this to kilograms, we're going to need to use the equality 1,000 grams is equal to 1 kilogram, which is then equal to 0.725 kilograms. That amount is going to go down in the denominator, and then by cross multiplying we get that X is equal to 0.16 moles of silver bromide. Okay, now that's great that we get moles of silver bromide, but we want grams of silver bromide. So we have one last dimensional analysis to do, so 0.16 moles of silver bromide. Okay, the GFM, which I've already calculated out, is going to be 187.8 grams, which is equal to 1 mole. Now, if we start with moles, we need to have the mole on the bottom. And when we solve that, we find that in this 0.22 molal solution, we're going to have 30 grams of silver bromide. And that's it. It's a little bit of dimensional analysis involved with this new equation, but you should be pretty good with that as we've done it for a couple months now. All right, a mole fraction. This is simply comparing the moles of our solute to our total moles in the solution. There's no unit for mole fraction. However, we do represent the symbol as an X with the name of which of the parts of our solution we're looking at. So what is the mole fraction of ethanol when 23.2 grams of ethanol are mixed with 73.1 grams of water? Just so you know, and you might want to add this into your notes, ethanol has a formula of C2H6O, so we're going to be needing that in order to do some grams to moles. So our mole fraction needs to be in moles, so we're going to need to take our ethanol amount and our water amount and convert them each individually into moles. So 23.2 grams of ethanol using the GFM, which is 46.0 grams, which is equal to 1 mole. We only have 0.5 moles of ethanol present. For water, we have 73.1 grams. GFM is 18.0 grams, which is equal to 1 mole. And when we get that, we get 4.06 moles of water. All right, now that we have all of our parts in moles, we can go ahead, find our mole fraction for ethanol, which is going to be equal to the amount of just ethanol divided by the total amount of all the parts. So we have 0.5 plus 0.06 down in our denominator. And when we solve that, we get a mole fraction for ethanol as 0.11. And that's it. So simply just, again, using some dimensional analysis in order to calculate a mole fraction. All right, well, thank you for listening to all the little distractions in the background. Make sure you just review this quickly to just for yourself to figure out molality and mole fraction. We'll go over this in class